Okay guys, I'm going to walk you through this homework and explain to you how you pick up more marks. Remember these sessions are all about developing your exam techniques. So listen carefully to the way I kind of approach things. These objectives at the start, just a reminder that they link in nicely into your objective sheets, and so you'll see as we go through how some of these things come up, such as the structure of a nucleotide, the difference between RNA and DNA, synthesis and breakdown, and the structure of ADP, including ATP as well. So that is a linking into a nucleotide. So don't forget those. This is where it feeds in. Right, question one, okay, it's multiple choice one. At the start of your exams, you're going to have 15 to 20 marks of multiple choice on some of your papers. So it says it shows an organic molecule. Now remember, you'll see this cold for the first time. In an exam, it won't follow on, but hopefully straight away you'll recognise that it is a nucleotide. Remember, join lots of these together to make a nucleic acid. What bond is formed when a molecule is polymerised? So polymer means making lots and lots of them join together. So I've got a couple of options here. Remember, this is for sugars. This is for proteins. So I'm down to these two types of ester bonds. Well, it's a phosphodiester because a phosphate will join onto another nucleotide, and we've got two ester bonds, so it's phosphodiester. So D. The following statements about the structure of DNA. Which of the following is true? And so this is one of the ways they'll kind of make it a little bit more challenging, is by giving you sort of multiple choice, but then select some different combinations. So it's not multiple guess essentially. So purine base is a pair of pyrimidine bases. Well, that's true. So purine, remember, there's two types of nucleotides. Ones that roughly form a single hexagon, and ones that roughly have a double hexagon, or two rings, as part of their nitrogenous base. And I always remember it that the purines are the double ones, and the pyrimidines, because pyramids sit on their own, it's a stupid analogy, are the single ones, but it doesn't mean I actually remember it every time. Okay, right, so yes, they always go together, so that's true. Phosphodiester bonds link adjacent nucleotides, we've just seen that, so that's true. And there is equal amounts of adenine and guanine. Good question. Remember, A bonds with T and G bonds with C. So it doesn't, a sequence of amino could go AT, AT, AT. Well, there would be an equal amount of the complementary nucleotide, but it doesn't necessarily mean we have to have any of the other one present, so that is not true. So it's statements 1 and 2, so it's B. Again, I always like to walk through these things, not just launching them the right answer. There's plenty of time in the exam to go through these and think about it. Which of the statements A to D about the nature of the genetic code is incorrect? So let's not make that silly mistake. It's degenerate. I'm not sure what that means for the moment, so I'll come back to it. It's a triplet code. Well, that means ATT, 3 letters equals 1 amino acid. It's overlapping. Well, that kind of means that those 3 letters might make the first amino acid. Let's just call it glycine. But it also kind of means that you could equally read it TT if we can't carry it on, that the next 3 letters could be doubled up. Well, that's not true, it's not overlapping, there's no doubling up. It's universal, isn't all organisms have it. Well, I know overlapping is wrong. Actually, what degenerate means is there is more than one code to get to the same amino acids. You might find AAT equal the same amino acid. So there are 3 terms you do need to know. ATP is described as the universal energy currency. As I described, the structure of ATP is similar to and differs from the structure of a DNA nucleotide. So this is one of the real classic things that we need to know about. Just going to have a look. So I've got 5 marks, 5 points. So let's try and make 5 comparison points. So first of all, well, I know the number of phosphates is a bit clear in the question because it's T, which means 3. So ATP has 3 phosphates versus 1 in DNA, and it doesn't actually say which DNA molecule. So I'm going to go out there and say adenine. But if I'm thinking adenine, there's nothing there that says I have to talk about adenine. The structure of ATP is similar and differs from the structure of DNA and nucleotides. So I could say nucleotides can be Like ROs and falls. It could be adenine, thymine. I guess if you're stuck, you could go with the cytosine and guanine. Now, just take the time to review what you've written. Nucleotides can be adenine, thymine, cytosine, and guanine. I'm not entirely happy with that. What I kind of mean is they contain nucleotides contain a nitrogenous base, which can be any of those four. Now, I'd expect you to write it a little bit longer, but I'm trying to keep this video short. So I made sure I'm happy with my answer. Is that a comparison? No. So I need to say it. Whereas ATP only has adenine. So first paired point, second paired point. Right, I need a third one. I'm a bit stuck, so I'm just sort of sketch out what I know about the structure. So I remember this kind of diagram of a rectangle, pentose, I can't draw a pentagon, and a circle. And then I know for ATP is 3 circles. So we've talked about the phosphates being different. We've talked about the nitrogenous bases being different. So what about the sugar? So adenosine triphosphate. So I'm going to go out on a limb and say ATP has a ribose. No, I'm going to change my mind. I'm going to go with they both have a deoxyribose. Because it does ask for similarities. It's RNA that has the ribose. Both have deoxyribose. So it's okay to change your mind. Both have deoxyribose. So I feel like I'm running out of points, but that's because I focus only on the similarity, on the differences. I haven't looked at the similarities. So how are they both similar? Well, I could go with. I know it forms a phosphodiester bond. I could get clever. Maybe they both contain an ester bond. And they've both got I've already got both have deoxyribose. I could say both have a pentose sugar. They both have a phosphate group. Obviously, there's difference in numbers, which I've said. So I could shoot myself in the foot a little bit, and where I've got 3 phosphates up here, I could actually sell myself short and not put enough in. Just kind of quick look at that mark scheme and just see where we missed out any marks. So I'm going to point this mark scheme out just so we're here. So they've laid out similarities. Both have got pentose sugar. Both have got a phosphate. Both have got adenine as a base. That word adenosine needs to be very careful because that means that it is the adenine plus the ribose sugar. Yeah. Watch what they don't like though. They don't like phosphate heads. There's a lot you can learn from this column. They say ignore labeled ignore. Less of the bases is okay. Differences then. So deoxyribose. Oh my gosh, I told you wrong. So anyway, you've seen it from the horse's mouth. Teachers get it wrong too. Okay, it's what I first went with. DNA has 1 phosphate, and ATP has 3. We had that point, didn't we? DNA nucleotide has 4 different bases. We had that point as well. So we've got our kind of key differences there. Let's look at our last question. DNA and RNA are nucleic acids. Describe the structure of a DNA nucleotide. Okay, again, in the answer, you should spell the names of the molecules correctly, great. And you may use a space below to draw a diagram if it helps. This usually means you, rather than should, pretty much must. Okay, don't accept it as a maybe. So let's draw this diagram first of all. We've just done it. So the structure of a DNA nucleotide. So DNA. So this RNA is a bit of a red herring. So I probably need to be a bit careful now. And here's where I do need to be careful because I know, I'm kind of doing this wrong deliberately, that I've been very sloppy about where I have put my bonds. Okay, I'm just going to let you sort of ponder that for a second because that would not get me a mark. Okay. So what am I going to be looking for? So describe the structure. So I'm going to say it's 3 marks. So it's got a phosphate group. Oops. I'm saying after describing, it's got a deoxyribose. It's got a, and be careful my words here, a nitrogenous base. And which could be, so it's 3 points. It hasn't asked for 3 things specifically, so I can give more, which could be guanine, spell it right, cytosine, thymine, and adenine. This is one that people spell wrong. So I kind of made 4 points, so I'm quite happy with that. Right, hopefully you had time to spot the mistakes. So really should have put my oxygen in there, shouldn't I, on the top. And then just notice where they come from. They actually come from each of these 2 branches, number 1 and number 5. So that is what my nitrogenous base is attached to, and then this one is what my phosphate group is attached to, carbon number 5. So just be a little bit careful about how you label those and how you spell those out. Moving on, last couple of questions. Okay, so describe how 2 nucleotide chains in DNA are bonded together. And it's described to give the facts. 4 marks on 4 points. Well, the easy one is it's hydrogen bonds. But that's not 4 marks. I need to give them obviously more marks than that. And so I need to be thinking about really what are my marking points. Well, I do know which ones go together. A, it goes with T. And usually they always want this as a pair. G goes with C. Selenium 2, right, what do I know about adenine and thymine? Well, I do happen to know that adenine and thymine form 2 hydrogen bonds. Because I was in the T for 2, and that means that G and C, G plus C, it form 3 hydrogen bonds. Okay, still only at 3 points, need a 4th one. I could mention it's anti-parallel. I'm not entirely convinced that that is about how it's bonded rather than how it's arranged. So I'm going to put the 5th point in rather than just stop there. And I'm also going to mention about purines and pyrimidines, because I know that the pyrimidines, I said it earlier, always bond with the purines. So an A goes with T and a G goes with C. Right. So guys, hopefully from that you just picked out a couple of little kind of key pointers on how to improve your exam technique. And also you'll remember forever that ATP has a ribose sugar because Dr. Rose got it wrong.